In our description of scatter plots, we were talking about, those three things, overall shape, strength, blah, 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 with the cloud of points, right? And one way that we can describe the direction of the cloud of points is with this concept called association. And association is simply a kind of a visual pattern to the points. And there are two types of association, positive and negative association. When we talk about positive association, I think of this in a graph, both of these. Um, and if you talk about like, variable one and variable two, just as general ideas, um, positive association means that if you look at kind of the average values for the variables, if you have higher than average values of one variable, that corresponds to higher than average variables or values of the other variable. So meaning you're going to get this sort of behavior going on. Okay, that's why it's kind of a positive association. It looks like if we were to draw a line in there, we would have a positive slope to that line, right? So positive association, higher values of one variable indicate generally higher values of the second variable. Okay. Negative association, on the other hand, visually it's going to look kind of like a slope with a negative line if we were to draw a line through it. But again, formally, negative association is if we have higher values of one variable, or higher values than the average of one variable, the other variable we get lower values than the average of the second variable. So here we would have high value or higher values than average of variable 1, but that would correspond to lower than average values of variable 2. Okay, so that's the formal definition to negative association. So you can capture those here. Okay, now the just as association was a visual pattern, we, of course, as mathematicians and statisticians, need a way to measure that formally using formal mathematics. And that is where correlation comes into play. Okay? So correlation is simply the measure associated to association. But more specifically, it can measure the direction and strength of the uh, linear relationship of a linear relationship between two quantitative variables. And I have to stress it is what we're going to see in this course is linear correlation, so how well it fits a line. But nevertheless, we have that. So again, correlation can describe the direction and strength of the relationship, and specifically the linear relationship. Okay, so that would, if we can determine the correlation, that's effectively two of the three things we need for the scatter plot. Great. And so mathematically, how we determine correlation is through this nasty formula. Okay, it's called Pearson's correlation coefficient, and this is specifically for a linear association. Okay, so if we, are interested in how well it fits a curve that is not a line, then there are different types of correlation coefficients we can calculate. Okay, so we will see this in Excel. Okay, we're not going to do this calculation by hand. It is god awful. Okay, but just some notes before we get into Excel to calculate it. When we are talking about linear association, if we're seeing how well it fits a line, if we have this R value that we compute, if it's greater than 0 or positive, it means it has positive association. So we would see this value. So in these instances, R would be bigger than 0. Similarly, if we visualize in a scatter plot and we see negative association, R, this correlation coefficient, is less than 0. Okay? Another thing to mention is that it does not distinguish between explanatory variables and response variables. Okay, so if you have your scatter plot, your axes flipped, well, this is going to be okay, but I'm still going to deduct points when I see your scatter plot. So even if you have your axes switched, the value of R will remain the same. Okay, and then the other thing is that R does not change if you change units. Okay, so for instance, let's say your horizontal axis is in feet, but you don't want it in feet, you want it in inches. Great, change the units. It's not going to change R. Okay, so just be aware of that. Okay, now the fourth thing I want to draw a picture with is that R as a value is between and including -1 and 1. Okay, so if we think about a number line, and we think about 0, here's 1, here's -1, and then there are going to be a couple boundary places. There's going to be, oops, I want to draw that further out, and then about here. So -0.7 and -0.3, or 0.3, yeah, and then positives of those as well. Okay, when we were describing a scatter plot, we use this language of strong or weak, right, to classify the strength. So R does classify the strength, and here are the specific boundaries. Okay, so we know that on the left side of 0, this is all negative, right? So there's negative association here, negative and negative. On the right side, that's positive. So positive, positive, positive. Okay. Now so that tells us the direction. We want to know the strength. And what we're going to say is that if we have values between 0.7 and 1 in absolute values, this is going to be a strong relationship. So I'm going to say strong and strong. And similarly, if we're close to 0, that means we have a weak and a weak association. In the middle, we're just going to say, well, that's moderate and moderate. Okay, so depending on the values of R, we can say both the strength and the direction of the association. Okay, so now is the fun part where we get to do the math quickly in Excel. Okay, so we're going to go back to example 3.1 and calculate the correlation there. And here is our example returned about that NEA change in fact gain. To get the correlation, I'm going to go to Data Analysis, and make sure you have the Data Analysis tool pack. And then there's a nice little correlation feature in there. So I'm just going to select that. Okay, and input range, I'm going to just drag over the data. And again, remember, one of the properties of correlation is it didn't matter. It didn't really matter which one was selected first. Okay, and then the only thing that I'm going to do here is change the output range to be a random place in the cell with nothing nearby. Click OK, and okay, so you get some numbers. Okay, the ones we're going to ignore, and the intersection of column 1 and column 2, that's the number, that's my correlation. Okay, so I'm just going to say, if I click in here, that is going to be my correlation. My correlation coefficient, my Pearson's R. Okay, so that's all we have to do. And so this one, since it is negative, we have negative association, but furthermore, using that scale that I just mentioned, it should be strong negative actually, despite that kind of striking deviation. Okay, so this one actually, I would go back and modify this because it's not weak, it's actually strong. Okay, so there we go. As a final wrap up, I encourage you just to make a visual summary of the values of R, okay, based on that kind of scale. So I have different values of R shown here. Take a moment and sketch a scatter plot of each of these, or at least a cloud of points that might be associated with these given values of the correlation coefficient. And here are my examples. So the higher the R value is in absolute values closer to 1, the tighter the cloud of points should be. As you decrease the value of R towards 0 in absolute values, then the cloud of points is going to become more dispersed.